A new space startup has just come out of stealth mode. They are called LongShot, and they have a crazy idea. Why not shoot things into space with a really big gun? It sounds crazy, but it doesn't break any laws of physics. If you can accelerate something fast enough, you can send it into orbit. In their recent test, they have managed to reach Mach 4.6. That's still short of the necessary speed to reach orbit, which would be Mach 23. Still, you have to start somewhere. Their rationale is that to build the space economy, you will need billions of tons of raw materials in space, such as steel, gases, water, and fuel. These raw materials can be accelerated really fast without destroying them, unlike humans. Their team has decades of experience working for top space startups in the Bay in California, and are backed by experienced investors. As LongShot explains, launching things to the edge of space with the gun isn't new. The US Army was doing this in the 1960s. They fired 100-pound projectiles 160 kilometers to the edge of space at Mach 6. That's not enough to get into orbit, but it shows the idea works. If they can manage to shoot something into orbit, then the marginal cost per kilo of payload will be very low compared with a rocket. CEO of LongShot Space Mike Grace says, "Rockets are among the greatest feats in human engineering, but they're an overly exquisite solution to the problem of sending megatons of inert mass to space. You need something that is dumber and much cheaper both to build and to operate." LongShot are betting they can get payloads down to as low as $10 per kilo, which is a massive reduction compared to the $6,000 per kilo price of a rideshare on a SpaceX Falcon 9 rocket. Technically it's not a gun because it doesn't use an igniter, but it has a barrel and it shoots things really fast, so I'm going to call it a gun. Okay, let's look at the technology they are using. What kind of gun do you use to shoot payloads into orbit? A modernized gas gun. This is the type of device you need when you want to shoot something really, really fast. They are typically used for scientific research or for testing material resilience. This technology is not new, it's been in use since the 1940s. Let's explain how the device works. The idea is simple. You start with a chamber, and inside this chamber you compress a gas. Something light, such as helium, because it expands quickly. Then you need a barrel. This is connected to the chamber of compressed gas. At the side of the barrel you have your projectile, or in the case of LongShot, your payload. Then, using some kind of release mechanism, you turn a valve that opens up the gas chamber to the barrel. The highly compressed gas races out of the chamber into the barrel and propels the payload forward. Think of this as a kick stage for the payload. To get the speeds needed for space, boost stages are added. As the payload passes the boost stage cylinder, a valve releases the compressed gas into the main barrel that pushes the payload to an even higher speed. You keep adding boost stages and lengthening the barrel until you can get the necessary exit speed from the barrel you want. In practice, this method of propelling a payload gets you up to maybe Mach 7. To get higher speeds, you need to do some fancy extra things, such as squeezing the payload from both sides. That's a future upgrade though. For now, and for the next gun, they will just use gas compression to accelerate the payload. That's it in a nutshell. That's how a LongShot space gun works. Let's now discuss the length of the gun. One consideration is what is the maximum acceleration you want to induce on the payload. The higher the acceleration, the fewer payloads you can carry. LongShot wants to limit maximum acceleration to 500 to 600 times the force of gravity. To keep acceleration no higher than 600 g, the barrel of the gun needs to be long. That's the trade-off. Lower acceleration means longer barrel. For comparison, rocket launches typically exert around 3 g of acceleration to payloads. For a Mach 5 system, the barrel length will be around 80 foot long. For a Mach 10 system, the barrel length will be the size of 2 to 3 football fields. And for a Mach 25 orbital system, the barrel will need to be several kilometers in length. The full system will use an on-site solar farm to power the compressed gas pumps and a low-pressure tunnel. Still, it should be much cheaper than an orbital rocket. Another potential problem will be the noise. Each time the gun is used, it will create a sonic boom. Given it could be fired many times a day, it will need to be located in a remote location. Let's look at the current LongShot gun, which is a tech demonstrator. The current LongShot accelerator is located in Oakland, California, and consists of a kick stage, providing the initial impulse, followed by 3 boosters along the length of the 60-foot barrel. It is capable of accelerating payloads up to 6 inches in diameter to Mach 4.2, and I believe it's recently been upgraded to Mach 4.6. The tech demonstrator was built to measure the speed and location of the projectile in the barrel, implement high-speed gas injection, develop safe and rapid test operations, and to demonstrate building low-cost hardware that meets challenging performance constraints. Okay, let's go over a few milestones the company has achieved so far. So in 2024, the current LongShot gun has reached the speed of Mach 4.6. LongShot has built a prototype from its facilities in Oakland, California, but a dense urban location is not the best place to site increasingly large space guns. The Oakland prototype reached 4.6 Mach speed, but going any faster would mean a longer tube and the use of highly combustible hydrogen gas. CEO Mike Grace said, "We'd prefer not to blow ourselves and other people up. We decided to just declare victory and withdraw at Mach 4.6. In September 2024, LongShot received $8 million in new funding. The startup has received $8 million in funding to build a giant cannon that can launch raw materials needed for the orbital economy, including $2 million from the US Air Force contract. This money will be used to build a larger version of the gun." What are the upcoming events for this company? They are constructing an 1,800-foot long gun in the desert to provide hypersonic testing to the Air Force. They are upgrading their gun to fire about Mach 5, with future plans for Mach 15 and then Mach 25, fast enough to put payloads into orbit. Let's examine the Mach 5 gun a little further. When you are building a giant space gun using a highly combustible gas like hydrogen, California is not the best place to work. That's why for their new Mach 5 gun they are moving to Nevada. Lots of open land just in case an accident happens. Their 500-meter long gun with more boosters should be able to push 100 kilo payloads to Mach 5. And thanks to their recent funding award by the US Air Force, they have the money. The mile-long strip of land in Tonopah, Nevada, a town that's home to the secretive F-117 stealth bomber, will enable LongShot to demonstrate launch capability to prospective customers, including the US Department of Defense. LongShot is now awaiting approvals from the Federal Aviation Authority to begin construction on the massive Nevada system. Okay, that's it for LongShot. We wish them the best of luck with their crazy space gun, and of course we'll keep you up to date with all their progress. Thanks for watching. Please like and subscribe to see more videos like this on other small startup companies in space. We'll keep you covered with all the news on the small commercial space startups. See you soon.